Hi everyone. Today I'm going to share a bit of tips on how to write mathematical formulation in a professional way. Uh, this will be useful for your writing your thesis. Okay. So mathematical formula forms many bases for engineering law. So you are expected to write some in your thesis. It is important that your thesis is properly written so it can be properly disseminated and so others can also emulate your work. So that's why your math needs to be written in professional way. To do this, lucky for us, there's tools in Microsoft Office called Equation Editor that can be used to make use of this. This is actually based on a Unicode library, and there are also options to make use of LaTeX script, which is actually an open source typesetting tool. To access this, either you can go to Insert in this Microsoft Office, for example, and then you can simply hit the Pi button over here or the equation tools. Or you can simply hit alternate and then with this plus equal symbol. So alternate plus the equal symbol. Okay. So these symbols should be at the top of the keyboard. Okay. So for most of the tools, it should be available here. You can make use of all the symbols in the ribbon, and then you can also choose from different populations, such as vector, matrix, numerator or denominator, or fraction. It's quite easy to use, but it can be tedious sometimes for large equation. So there's another alternative is we can write the code straight away. For example, you can use the Unicode command. There's a list of what you can write. For example, here this is how you can write a bracket with fraction. You can also write fraction. Sometimes it's much faster this way. You can also write vector. So to do that, I provided you with a cheat sheet through this link. You can scan this QR. Another alternative is to use LaTeX. So LaTeX is another code, actually is for typesetting, creating high quality PDF. I've also provided the cheat sheet here. For example, if you need to write the Greek letter, rather than choose what Greek letter that you know, if you know the Greek letter already, you can just simply write this and then it will come out. Okay. Let's do some example. Now let's do some examples. So I'm in my Microsoft Words now. I can go to the insert and then hit the equation. Okay. I want to write the sine law over here. Okay. So there are two ways. Either you can choose what you want. For example, I choose fraction over here, and then I can go find sine, and then I can insert sine A over A. Okay. But that means I will need to search through each of the item, and then only I uh, right through this. So it can actually be quite tedious. It's useful, but it can be quite tedious. So, for example, here I need to always choose one at a time. So B over B. And of course, I can also just copy and paste and then simply changes. Okay. Um, it's quite useful, but in some ways you will notice that you are writing the same thing. For example, you're doing the fraction over and over. So it's actually useful to just make use of the code. Okay. So to do this, what we can do is simply enable first the equation. Enable that, remember, is alternate plus equal sign, and then you will be able to see this equation. So we can just simply write sine, and then if you hit space, you'll see a box appear, and then sine A over A, and then you can put the slash button over A, and then it gives you this. So in this case, this is not what we want, but actually the reason why is because we did not give a proper location of the slash. So in this case, I don't want it to be next to A, so I can just get out of A by clicking the right arrow, and then put the slash and then over A. Okay, so I got sine A over A. Then I can do the same for the rest over here. Okay. I'm going to show one example here, which is your Navier-Stokes equation. Again, alternate plus minus equation. Okay, plus equal. So then you can write the partial derivative is just slash partial. So how do you know it's slash partial? I can go back to the cheat sheet that I showed earlier, or I can check here. It's written that it's slash partial. Okay. So here we have the partial, sorry, partial derivatives. So I want it pulled. So Control B over again partial, and then space. Sorry, yes, space, and then T, and then you got what you want. Okay. And then plus I have U, and I need to put dot, and this dot is actually bullet here. And you can check here is bullet over here. And then that is a Greek symbol nabla sign. I'm going to put nabla and times with U. Okay. Then equal to negative again nabla. So you need to know a bit of the Greek symbol in order to make use of this effectively. Plus, and then that's another Greek symbol new. And then again nabla. And I want to make square. So to make square, I need to use this hat or this upper inverted, the upper hat there, and I put two, it becomes hat. What about if I want to make subscript? So if I want to make subscript, for example, let's just try with U. I can put U and then underscore one, for example, to make it into U1. In this case, I just want to put it U. Okay. Then plus G. So that's how you can actually write it. Actually, in this case, I don't need to go and find what is delta, what is nabla, and so on. So if you already know what it is, I can just do it that way. So it's actually quite handy. So how do you know where all the codes are? You can just scan the cheat sheet and then you'll be able to see all those code that we can use. And that actually makes it quicker actually in some case. Another choice is actually quite interesting is to use this ink equation. So if you go to the ribbon for the equation editor, you can actually see there's this menu will come out that you can actually write, you can actually scribble here and then the equation will come out. Once you're done writing your equation, then this equation must be referred back in text. And then you can also link that equation back in text. Ideally, well, not ideal, all equation actually must be numbered. And then all the parameters and variable in the equation must be described either in the text or in a table. Okay, let me show you another example. Okay, so here we have, for example, we have this equation of the area of a circle. So when we give this equation, ideally we need to provide a number of the equation so we can refer back to the equation. Okay, so in this case, I give number one, and then I need to refer to the equation. So referring to equation one, which is this equation, A here describe the area of the circle. So I describe A, R describe the radius of circle. So pi is obvious, so we don't have to define everything. I'll show you one example as well, how to do this. So let's say I were to have one equation. I'm just going to choose one from whatever that we have already. So I'm just going to choose a Fourier series here. So how do we add the equation? So we can actually put this in the center and then take one line and then we would this way. Go to insert, sorry, go to references. So references, insert caption. You'll see that there's this option to change this to equation. Okay, and then I'm going to exclude the label because I don't want the word equation to come out. So if you click this, there will be word equation, but I don't want it. So I'm going to take it out and then hit OK. And then I put the other caption, the other bracket, and then I can set it aligned right. Okay, so that's how I can number this. Okay, so here you can see just now it was number one, so it sequentially followed the number. So this is equation two. And then I can refer back this equation. I can say, for example, where equation here, and I can call the equation back by going to insert and then hit cross-reference. And then I can search equation and the reference type. I can see all the number here. So I'm going to choose equation two. Then it appears on the screen. Then I can decide where equation two describe For example, in this case, is Fourier series. Okay. So with this, we can have a good linkage of these two equation and the main text. And you can also see, I can actually now click this equation and see it goes to this equation. So imagine for a long document, this is very helpful to search back the equation. Okay. So with that, so with that, I want to conclude what we have covered today. Thank you, and I hope what we gave you quite beneficial for your thesis. Thank you.